Hello everyone, I am Dr. Digambar Ufade, Assistant Professor from KTHM College Nashik. Today we are going to study the important distribution, that is binomial distribution. Binomial distribution. In the last lecture we have seen the Bernoulli distribution. Bernoulli distribution occur when there are only two outcomes like a success and failure. And if we repeat that experiment n times, if Bernoulli experiment repeated n times, we get the binomial distribution with parameter n and p, where n is the how many times we are repeating that experiment and p is the probability of success. The definition of this Bernoulli distribution is a discrete random variable capital X is said to follow binomial distribution with parameter n and p if its PMF probability mass function is given by probability of x is equal to x is ncx p raised to x q raised to n minus x. X takes values 0, 1, 2 up to highest value is n. The relation between p and q is p plus q is equal to 1. Your value of p is lies between 0 and 1. And it takes the value 0 for other terms otherwise. This is the PMF of binomial distribution. Then to find the mean of binomial distribution, mean is denoted by expectation of x, which is equal to summation over x takes, here the range of x is x takes value 0 to n x into probability of x is equal to x. Here the range is x takes value 0 to n x, probability of x is equal to x, PMF is ncx p raised to x q raised to n minus x. Then we put the formula of ncx. It takes the value x taking value 0 to n x. ncx is n factorial upon n minus x factorial into x factorial. P raised to x q raised to n minus x. Here for x is equal to 0, the answer of this term is 0, so we change the range x from 1 to n x into n factorial as it is n minus x factorial into x factorial we can write as x into x minus 1 factorial. P raised to x q raised to n minus x, which is equal to, so this x will get cancelled. N factorial we can write as a, first we write a summation over x taking values 1 to n. N factorial we can write as n into n minus 1 factorial, and the value of n minus x factorial n minus 1 minus in bracket x minus 1 is same as n minus x factorial, and the term x minus 1 factorial is remaining. P raised to x we can write as a p raised to x minus 1 plus 1 to adjust the x minus 1 here, and q raised to n minus x is same as n minus 1 minus in bracket x minus 1 is same as n minus x. So which is equal to summation over x taking values 1 to n, and this n and p raised to 1 we take outside the summation. So what is np outside, and what is remaining n minus 1 factorial upon n minus 1 minus of x minus 1 whole term factorial into this x minus 1 factorial, p raised to x minus 1 and q raised to n minus 1 minus of x minus 1. This is the binomial expansion of p and q. So which is equal to np and p plus q. How many terms are there? N minus 1 terms. So raised to power n minus 1. But we know p plus q is 1. So np bracket raised to n minus 1. So finally we get the answer np. So this is the mean of binomial distribution. Therefore mean is equal to np. Then we calculate the variance of this distribution. To get the variance, as already we discussed the definition, variance of x as the formula expectation of x square minus expectation of x whole bracket square. So this expectation of x already we calculated. So we have to calculate the term expectation of x square. So we use the factorial moments here to get the expectation of x square. You know expected value of x into x minus 1. This is the second factorial term which is equal to. So here summation over x taking value 0 to n x into x minus 1 into probability of x is equal to x, which is equal to. So for x is equal to 0 the answer is 0. For x is equal to 1 also. So we directly change the range here, x taking values 2 to n x into x minus 1. Probability of x is equal to x is ncx p raised to x q raised to n minus x. Then which is equal to, so we write the expansion of ncx x into x minus 1 n factorial upon n minus x factorial into x factorial, and p raised to x q raised to n minus x as it is, which is equal to. So we, to cancel the term x into x minus 1, we expand this x factorial. Similarly we expand n factorial also. So summation over x taking values 2 to n x into x minus 1, we expand n factorial as n into n minus 1 into n minus 2 factorial upon this adjustment write as it is, because n minus 2 minus of x minus 2 is the same term. X factorial we can write as x into x minus 1 into x minus 2 factorial. Then p raised to, I adjust here x minus 2 plus 2, and q raised to I write as it is, because n minus 2 minus of x minus 2 is same as n minus x. So this x into x minus 1 gets cancelled. So what is remaining? It takes the values from 2 to n into n minus 1 into n minus 2 factorial upon this n minus x factorial as it is. This x into x minus 1 gets cancelled. What is remaining? X minus 2 factorial, p raised to x minus 2 plus 2 and q raised to n minus x, which is equal. So we take a constant term outside the summation, this n into n minus 1, and p square we get the outside the summation n into n minus 1. What is remaining inside? Summation or x taking values 2 to n minus 2 factorial upon n minus x factorial x minus 2 factorial p raised to x minus 2 and q raised to n minus x. This is the binomial expansion of p plus q, and the total term is n minus 2. So which is equal to np square into n minus 1, and this is the expansion p plus q, expansion of p plus q raised to power n minus 2, but we know p plus q is 1. So finally we get answer np square into n minus 1. This is the answer of what? Second factorial moment, that is expectation of x into x minus 1. But we are interested in expectation of x square, so we take multiply inside, so we get expectation of x square minus expectation of x is equal to n p square into n minus 1. So we are interested in expectation of x square, so we take expectation x in this side. So finally we get np square n minus 1, and this expectation of x is np, so plus np. Then we are interested in variance of x. Variance of x has the formula expectation of x square minus expectation of x whole bracket square. So expectation of x square we calculated here. I multiply inside, so you will get n square p square plus np square plus, sorry, here is minus np, np n square p square minus np square and plus np, and minus expectation of x is np, and that is n square p square. So what is remaining? This n square p square gets cancelled, np minus np square, and if you take a np common, what is remaining? 1 minus p. 1 minus p is q, so np q. Variance of x is np q. Then we calculate the moment generating function, that is mxt of this distribution. Mxt, moment generating function of binomial distribution. Mxt has the formula expectation of e raised to tx, which is equal to, so by definition we take the range from x taking value 0 to n e raised to tx into probability of x is equal to x, which is equal to x takes the value x from 0 to n e raised to tx, and probability of x is equal to x is ncx p raised to x q raised to n minus x, which is equal to x taking value 0 to n ncx, this the power of e raised to tx and p raised to x is same, so e raised to t, p e raised to t bracket raised to x and q raised to n minus x. So this is the binomial expansion of two terms p e raised to t and q. So we write this as p e raised to t plus q bracket raised to n. So which is equal to, finally we write in this format, q plus p e raised to t bracket raised to n. This is the mxt of moment generating function of binomial distribution, that is q plus p e raised to t bracket raised to n.